Good morning or good afternoon or good evening. Welcome back to our third talk of the PyData track today at the Python Web Conference. And with me at this moment is Jatin Gupta, who's a data scientist at IBM. He's based in India, in New Delhi. And today he will be speaking to us on design thinking in AI systems. And I'm looking forward to hearing about ethical questions. Thank you very much, Jatin, and please proceed.
Thank you so much, Kim, for that wonderful introduction and for that Truman Show reference as well in the very starting. So as Calvin was also saying, I think in the opening note yesterday, that we have people from over 13 time zones. So I think I will also say a good morning, good afternoon, good evening, depending on what part of the world you're in. And yeah, thank you so much for logging in and listening to my talk. So today we're going to talk about design thinking in artificial intelligence systems. And before we start, just a very small introduction about myself. Kim already told you guys that I'm a data scientist at IBM. So as part of my job, I am adept with technologies such as machine learning, deep learning, neural networks, and all those buzzwords which are there floating in the air. And I'm also familiar with languages such as Python, Java, R. Incidentally, I'm also a Google Cloud certified professional cloud architect, an AWS certified machine learning engineer, and an Azure certified AI engineer as well. Please don't ask me why I've done a certification in all three, because honestly, even I don't know. I guess I was just curious to learn about the three different cloud platforms, and that's why I did it. Then talking a bit about why I want to talk about this is because I think before I started working at IBM, I had a bit of a design background. I used to work at an ad agency called McCann World Group, which I think some of you must be aware of. It's one of the largest ad agencies in the world. And then over there, I learned the ins and outs of design. I learned what are the fundamentals of UX. I did a bit of UI UX research as well, and I did a bit of wireframing as well. And in that time, I really thought to myself that design is something which can be incorporated to all walks of life, to all technologies, to anywhere where we have any bit of development. It can be implemented there. So when I started working as a data scientist at IBM, I guess I really thought to myself that, okay, whatever I learned in the field of design, I think that should be applied to the field of artificial intelligence as well, because as artificial intelligence is becoming more and more widespread, I think artificial intelligence also needs to be smarter, more intelligent, and I guess most importantly, more human. And I think that's where design thinking really comes in. And that's why we really need to incorporate design thinking and AI. I want to set the expectations with this talk, because I don't want any of you to leave this talk and think that I was expecting this, but I did not get this. I completely get it, because it happens with me all the time. So this talk is definitely supposed to be a good introduction to what design thinking is and how you can incorporate design thinking in artificial intelligence systems. Secondly, this talk is supposed to be a conversation starter amongst you, your employees, your fellow co-workers at your respective institutions. And this talk is also full of actionable items. Okay, maybe not full, maybe full is an exaggeration, but there are several actionable items that I want you guys to take home with you and really implement in your workspace as well, respective workspaces. Now, what this talk is not, this talk is definitely not a complete guide to design thinking and AI. I think I would be selling design thinking short if I say that this talk is all you need to know about design thinking, because it's not. Secondly, this is not just a talk. I don't mean to say that this talk will bring about a revolution, but all I mean to say is this is not any theoretical talk where I just talk, and you just listen. I say this before all my talks that I am learning just as much as you are right now. I'm just a normal guy who researched this topic and tried to collate as much information as he could, tried to summarize the points, and tried to show the relevant points to you. So if you have any points, any suggestions, and I would really love it if you guys can be as interactive as possible during the entire talk. I've spoken to Kim as well before, and I've told him that um, anyone can feel free to ask questions, and I would be more than happy to answer them, and I would be more than happy to learn from you. And thirdly, hopefully this talk is not boring. I mean, I love to talk. While I'm doing this right now, I'm really enjoying this. But my mother tells me that when I was a kid, I used to talk a lot. Uh, and even though I used to have a lot of fun, many of the people around me used to get very annoyed. And that is not something which I want to happen today. I want you guys to have just as much fun, if not more, than I am having right now. And I would love to have some good feedback at the end of the talk. So the $1 million question, what is design thinking, right? We really want to know what is design thinking. So just to tell you the roots of design thinking was originally coined by Stanford D School, the famous Stanford D School or the Institute of Design. And I think it was coined in 1969 or 1970. And the reason why it was coined was because at that time, the professors at Stanford, they thought that there's a lot of great products coming out and great services coming out, but even some of the best innovators and companies were not really catering to the end user in mind. And that's why they came up with this design process called design thinking. Um, Design thinking is essentially human-centered design. And it's about creating new ideas and solutions by really just understanding humans at the very core. And you try to understand the user, you try to challenge the assumptions that you have about the problem, about the user, and then you try to redefine that problem to really identify alternative strategies as compared to the conventional solutions or conventional approaches that you have. You can think of it, that's how I initially thought of it, was that it's basically reverse engineering, but in design. I mean, sort of, when you think of it, because usually we design the product and then we think, who is the end user? Here we are designing everything with the end user in mind, and then we are doing all the processes after that. So that's how you can sort of think of it as reverse engineering. uh, Fourthly, it's iterative and it's not always linear. Iterative, of course, means that it's repeatable. This process can be repeated at any stages of the AI lifecycle, and it is not always linear. Even though there are 5 phases to this process, which I'm going to explain later, it's not always in that bi-directional, one-directional, unidirectional phase. And also, we have to remember that this process is not exclusive to designers. As I said, design is something which can be incorporated to all walks of life, and AI is one of them. And something is relevant in the world when it is actively being commoditized and monetized. As we can see that world's leading brands such as Apple, Google, Samsung, IBM, etc., and even universities such as MIT, Stanford, they're all teaching courses. They have dedicated courses on design thinking. So there are 5 phases to design thinking. Essentially, there is the first phase where you empathize with your user. Second is when you define the problem statement. Third is where you basically ideate. You try to come up with as many ideas as you can, even though they might sound absolutely ridiculous. You try to come up with as many ideas as you can. Fourth is you build sort of like an MVP or many MVPs rather, minimum viable products. And then you try to test those MVPs and you try to get some feedback on those MVPs. And again, as I said, it's an iterative process. You go back to the whiteboard once you get your feedback, and then you repeat the same process. I'm going to get into the detail of all these 5 processes. But while I do that, I want all of you to keep in mind that I would be explaining these. Firstly, for these 5 phases of design thinking are not exhaustive. The very crux of design thinking is that it's not supposed to be a one-fit-all solution, and it's not supposed to be restrictive in any nature. And that's why, since we're talking about artificial intelligence, there are going to be certain nuances, certain elements, which I'm going to introduce to these conventionally 5 phases of design thinking. so that it better accommodates the AI lifecycle. So please keep that in mind while I explain and I dive deeper into all these 5 phases. So the first phase, which I personally believe is the most important of all the phases, is the empathize phase, where you really try to understand what the problem is at hand. You really try to understand the very core of what you're trying to solve. In this particular phase, you try to observe, engage, and empathize with the people to really understand their experiences and motivation. Uh, here, this is one of the most beautiful lines that I've seen. This is from IDEO, which is one of the apex organizations of design thinking. They say that in this particular phase, you have to put people first and users second. Whenever we talk about artificial intelligence or any other product or service, we often talk about consumers or users. But in this particular phase, we have to think of these users as people, and we have to think about what their likes are, dislikes are, actions are, thoughts are, etc. And the another reason why this particular phase is so important is because empathy really allows you to challenge your assumptions about the people and the problem at hand, and also about the world in general. So it really just opens a huge undefined box for you, where you can really explore all the opportunities which are out there. So there are several tools or exercises which you can really perform when it comes to empathizing with the people and the problems that they're having. One very common and sought after exercise which a lot of design practitioners do is building the empathy map, in which basically say, let's assume that there's this consumer that we have, or user rather, that we have, Jamie, who wants to buy a TV. So in the empathy map, you basically divide it into 4 quadrants. And one quadrant is what would Jamie think while or before buying a TV? What would Jamie feel? What would Jamie do? And what would Jamie say? So in this particular example, uh, when Jamie is about to buy a TV, she might think something like, "What is the best TV for me?" That is a very normal thing to think for a user. Then Jamie might feel overwhelmed by the number of choices that she has at hand. Jamie might do a lot of research, or she might check a lot of websites to compare the prices, to compare the specifications, to compare the warranty that is there. And Jamie might say things like, I was expecting something different to the salespersons or to the different people who are trying to sell the TV to the Jamie. So, how this exercise is really relevant to us is because it really helps us understand who Jamie is as a person. And it really helps us understand what are the pain points of Jamie and what exactly is she looking for. Then we have this particular gap analysis. This is basically the as a scenario and the to be scenario. You see the current state on the left. That is the as a scenario of the user. That means what is your user currently experiencing and what are their pain points. And then on the right hand side, you have the desired state, or sort of the to be scenario. So ideally, you would want your user to go from the as a scenario to the to be scenario, and you would try to determine what are the key factors to bring about that change, and you would try to build an action plan to bring about that change. This is a very common practice at IBM, which I think whenever a new person joins the company, everyone is required to undergo this one particular practice where we are given a mock sponsor user. Who is a sponsor user? Sponsor user is a potential user that you have identified for your product, who is willing to act in the best interest of your company and is willing to, say, for example, you build an MVP, or say, for example, you want to do this empathy map exercise on someone. So you contact one of your sponsor users and they give you the inputs, whatever they have in mind. And according to that, you build some strategic insights and you get some user feedback, which is very relevant to you. So the end user really becomes the very part of the development lifecycle, which is very rare when it comes to developing products and services. So that's how you can also make use of the sponsor user. I want you to think of this one robot. So this is a robot called Stevie, which has recently gained a lot of popularity. And this is presently being used in the elderly care homes in the US, Canada, and Japan. And this is not just any other normal robot which you find which will just serve you food or etc. They've tried to imitate an actual human-like robot who also conducts bingo nights, who also watches TV with these old people, who acts like a friend to these people. So now imagine if you were developing this robot for the elderly people, and if you were to say carry out this particular empathy map, what you could do is you could actually pick some of the old people as some of your sponsor users, and you could actually build this empathy map for those older users. You could also build out the as a scenario of the present experience of the older people, and then you could try to chart out an action plan as to how through AI, through building a robot for these people, can you build a better situation, a better experience for these people. So I just want you to put yourself in the shoes of, say, the developer of this robot and really try to think through as to how you could have alleviated the experiences of these old people. The second stage that we have in this particular, what do you say, design thinking process is where we define the problem statement. Whatever analysis you did in the empathize stage, you put together all that information and you basically analyze your observations, you define the core problems that you and your team have identified. And then you try to do something interesting. Say you have a business objective. Your business objective was to reduce the revenue by 5%. Sorry, increase the revenue by 5%, reduce the expenditures by 5%, something like that. So you try to convert that particular business objective to a human-centered problem statement. We'll get to that. How we do that, I'll get to that. And so this is basically a beautiful Venn diagram that, again, we at IBM, we are shown as part of our training whenever we join. So whatever business objectives you have, say again, increasing the revenue by 5%, you try to convert it to a user need, and you also think of the all the different technical constraints that you have with respect to the technology you have, with respect to the infrastructure you have, with respect to the architecture you can build, and then you combine all these three things, and you try to build an optimal solution between all of them, and that is a successful outcome. For example, let's look at this. So this is again, for example, if you want to convert a business problem to a user need, there is a very simple exercise which you can follow, which is called the 5 why exercise. 5 is the standard number. You can have 3, 4, 6 whys. So what you do is you take the initial problem that was given to you, and you try to question why. Then you get to some statement, then you question that again as well, why. And then again, until you reach some level where you think you've reached the root cause analysis. So for example, this is something which really hits home because I relate to this. Why is John falling asleep in class? Because he's tired. Why is John tired? Because he's not getting enough sleep. But why is John not getting enough sleep? Because he's staying awake too long at night. Why is John staying awake too long at night? Because he's unable to fall asleep when he goes to bed. And lastly, why is John unable to fall asleep when he goes to bed? Because he stays up and uses his phone. This is something which I guess hits home for a lot of us. But what we really realize in this case is that John thought that he is lacking, say, vitamin B12, but in reality, his core problem was that he's staying up late because he's using his phone a lot. So that really helps us identify what the core problem is. This is an example which I think is a bit more business oriented. For example, you see that your core problem, your initial problem was that your car won't start. Then you question why, because the belt is beyond life. But why is that? Because the alternator was not working. Why was the alternator not working? Because the belt was broken. And why is that? Because the belt was beyond life. So that's how you identified that the root cause was actually that maintenance was not performed. And there, the corrective action could be that you can actually schedule maintenance for that belt. And if you schedule the maintenance for that belt, you can get the car to start working. I'll take an example of my own client. We presently have an American client who I can't name, but they basically had around 15,000 customer care executives, which is a huge number. And initially, they gave us a business problem that they want to reduce their customer care. CC stands for customer care. They want to reduce their customer care executives by 30%. Then when we were at the drawing board, at the whiteboard, we tried to understand why is that. Then we figured out it's because it is hurting the company's finances. And why is that? Because having too many customer care executives performing mundane tasks hurts the company, as they should be performing more important tasks and better serving the client. So what we basically understood from that was they basically need a virtual chatbot to perform the mundane tasks for them so that the customer care executives can actually be trained in something else and move on to performing more analytical or more advanced stuff. So we basically reduced the initial problem to this core problem that we had at hand. In fact, I'd like to narrate a story. My girlfriend is a therapist. Uh, she's trained in psychology, and when I initially started dating her, which was around 4 years back, she told me about this therapy technique called cognitive behavioral therapy, or CBT. So basically, what it means is that you basically ask why, and then you understand the root of the problem. For example, I told her once that I feel tired in class all the time. At that time, I was in college. I feel tired all the time in class. So she asked me, why is that? I said, because I get bored in the class. She asked me, why is that? And I said, because I don't know, I just can't get myself to listen to the teacher. And she said, why is that? Because I said, because I just can't seem to find the teacher interesting. And then she said, why is that? And then I figured out the reason why the teacher is not interesting to me is because I do not have a good relationship with the teacher. So, so what I initially thought was that I just get this random wave of depression during my calculus class, or I just lack some vitamins. But actually, the problem was that I just did not have a good relationship with my teacher. So what I did was I improved my relationship with my teacher and really figured out that that was the core problem. And once I solved that, I was actually more attentive in class. So we can actually relate it to CBT, what we're doing here for our business scenario. I would like to share this quote from Charles Kettering, who was the head of design at General Electronics back in, I think, the 1950s. He said that a problem well defined is a problem half solved. And that's why this stage is all the more important. Okay, so a small exercise for all of you, if you guys can type in chat. Uh, they, you see two statements on your screen. One says that we need to increase our food product market share among young teenage girls by 5%. That is statement number one. And statement number two is teenage girls need to eat nutritious food in order to thrive, be healthy, and grow. I want you guys to answer, according to you, which statement sounds better, one or two. And I will come back to this once my talk is over. Just try to answer this question if you can. While we're at this, I also want people to define the 6 core AI intents, which we have identified. First is, you basically, why we do this is because you want to understand where your AI could be used. You want to understand whether it could be used to accelerate research and discovery, where you can basically process information quicker and you can make things faster. Second could be recommend with confidence, something like how Netflix recommends us movies and TV shows. Third could be you want to enrich your interaction, something like building a virtual chatbot. Fourth could be scale expertise in learning. Say there are some lawyers who are about to retire, but they have some valuable insights into law and order. So you want to take that information, summarize it, and share with your all the people at your legal firm. So that is something under scale expertise in learning. You want to anticipate and preempt disruptions. We saw a beautiful talk yesterday about debugging. So you want to ideally catch potential issues, you want to debug them, and you want to diagnose those issues as fast as you can. And then you want to detect liabilities and mitigate risk. There are just so many technicalities and so many contracts. You want to see whether there are any risks associated with any of them. You want to automate that process. You should, once you've tried to define what the problem is at hand, and once you've tried to identify what these 6 core, whether the way that you want to solve the problem, whether that falls under these 6 core AI intents or not, this will help you answer one question which I think none of the AI practitioners want to address, which is, do you really need AI for your problem, or is it just that your boss asked you to implement it? So once you try to bucket the problem at hand into these 6 core AI intents, you will really get an answer to this particular question, that do you really need AI? Because I think the very crux of design thinking in AI is that if you do not need AI to solve the problem, then don't use it. A lot of AI is used just for the sake of it. And as I said, that just because our boss asked us to use it. So you really want to answer that question. The third phase is now that you have empathized with your users, empathized with your problem, you've tried to define the problem statement at hand. Now you really want to ideate. You want to get as many ideas as you can out on the table. You want to think outside the box. Uh, what this means is, I think it's pretty evident. You want to break the shackles. You want to think outside the box. You want to not just think of the conventional approaches and frameworks. You want to think something more than that. And in this particular part, you want to diverge as much as you can. What I mean by that is do not restrict yourself. You can be as absurd, you can be as weird, you can be as ridiculous as you want to be. And you should prefer quantity over quality in this particular phase. There are hundreds of ideation techniques out there, brainstorming, brainwriting, worst possible idea, and scamper. My favorite is worst possible idea because uh, I usually do not come up with such great ideas. So that is my preferred way of ideation. Oh, and this is a beautiful animation which I did, which I'm very proud of. So remember, I talked about thinking outside the box. And this is how we are basically thinking outside the box. The box is, I hope you guys got. This is a diagram which is very dear to me. In fact, this is so dear to me that I've actually printed this and I have it at my workspace. Um, this basically talks about the fact that whatever idea you have, it keeps going in and out between boring, being absurd, and being brilliant. But the fun thing about ideas is that the moment you think that your idea is getting absolutely absurd, that is when you usually strike upon the most brilliant idea. So, my point being that go ahead, be as absurd as you can be while you're trying to ideate the best possible way to solve your customer's problems. And do not think much about whether this is feasible or not. Just go over quantity, not quality. Again, a wonderful quote by Albert Einstein, which I would like to share here. If at first the idea is not absurd, then there is no hope for it. Keep that to your heart, print it somewhere if you want, but please stick to it. Go ahead, ideate. I have Kim with me here. So, Kim, imagine, and I want all of you to imagine, not just Kim, not just the organizers at 6 feet up, but everyone who is listening. I want you guys to imagine what if 6 feet up were to organize Python Web Conference on the moon? Would be fun. Elon Musk would be one of the first people attending. But what if we were to do that? Secondly, what if 6 feet up were to organize Python Web Conference in 2019, approximately 1,000 years ahead, and also without the use of modern technology? We don't even know what technology would be like then, but just imagine without any technology, how would they organize it? Think of it. It could be absolutely absurd, and just think of it. The last two phases of design thinking is when we prototype and test. I put them together because they go hand in hand. This is an experimental phase because the aim here is to identify the best possible solution for each of the problems identified during the first three stages that we discussed. And here the idea is to produce several inexpensive MVPs, minimum viable products, which are basically scaled down versions of your products, which would be having slight variations here and there that you want to test out. And for the testing part, you can test it with the team itself, although that would not be ideal because you want a greater sample size and a very unbiased sample size as well. So try to share it outside your design team. And I would say involve the sponsor users, which you had in your stage one, involve them as well. In this phase, once you test the prototypes, you basically investigate the results, and they're either accepted, improved, re-examined, or rejected. And how why this exercise is really essential to us is because this helps the design team to really understand what the real user experience will be like and what are the various areas where they can potentially improve. I said in the very starting that design thinking is not a linear process always. And why I say that is because of this diagram. I think this diagram perfectly encapsulates whatever I wanted to say. So we move from stage one, we move to stage two, stage three, stage four, and stage five. But it might be the case, as I said before as well, we tested something, we found out that, there was something, we assumed something about our users, but it turned out to be the exact opposite. Say we assumed that all our users love uh, a face-to-face conference, but that was our assumption. But after testing our product, we found out that, hey, users actually love an online conference because they want to be sitting with their coffee, with their dogs, with their families while attending the conference. So we go back to the drawing board, we try to empathize with the users again, and then we try to build from scratch. So this is how it's an iterative process. You have to keep it doing again and again to build that perfect product. Some tips on how to test. You have to let your users compare the alternatives. As I said, make some tweaks in the MVP and try to get feedback from them. Show, don't tell. We are all very enthusiastic about the products we build, but let the user tell you what they feel about it. Ask users to talk through their experiences. This can be a bit weird in the very starting, but ask them to be a bit more wordy with how they're feeling, how they're thinking, and observe. You might find a lot of things which are implicit out there, but you want to really observe what your user is saying, thinking, feeling, etc. Um, and most importantly, don't forget to ask follow-up questions. I mean, this is so important, and ask open-ended questions because you don't want to ask questions such as, "Do you feel nice?" because that would be a simple yes or no. You want to ask questions such as, "How was your experience?" or "Tell me what you liked about this feature or what you disliked about this feature," because that would have a detailed answer from your user. I want you guys to watch this video. This was a video which went viral in India, and I just want you guys to watch this video. So ignore the audio. Even I don't understand what is being said there. But this is what design thinking and really get you. Not it won't get your head stuck in the fences of a gate. What I mean to say is, if you looked at what happened when the kid realized that the conventional ways of thinking, the conventional phase of getting yourself unstuck from a gate, which is the traditional pulling and pushing, that didn't work. The kid thought of a new idea, which was outside the box. So this is what design thinking is all about. I think the kid really summed it up. Even though he might not have followed all those processes, he does not really know anything about the theoretical part of the design thinking. But this is what design thinking is all about: just applying your brain correctly at the correct time. Now let's talk about AI ethics. This is a topic which is very dear to me. We don't have much time left, but I will quickly run through the ethical considerations in the artificial intelligence systems that we're trying to build. So why we need AI ethics, right? So when we look at news such as this, where basically there was an algorithm which was built which resulted in huge losses for a company. And when an algorithm results in a lot of losses for a company, you often start to wonder who to sue. Would you sue the company? Would you sue the algorithm? Would you sue the machine? Would you sue the investors? Who do you sue? So that is where something such as accountability comes in, because of course we have the AI to complement whenever something goes right, but who should we blame when something goes wrong? Or for example, look at this. This was when basically Amazon created an algorithm to recruit people to their company. And they found out that because of the training set that they had at hand, the AI was very sexist and it was very biased against women. So whenever it saw something such as a woman chess player or a woman captain on the resume of people, it automatically gave them less preference as compared to male candidates. So that's why we need AI ethics. These are just two examples, but there are many examples such as this where we see that AI is not being practiced ethically, and there are many focus areas of ethics. As per the latest research, there are around 67 areas of ethical focus. But I want to focus on these five because, as per research, these are the five ethical areas where there is the most amount of focus amongst governments and private institutions. So the first one is accountability. As I said before, who is to blame when something goes wrong? I believe that every person who is involved in the creation of AI at any step, be it the investors, the designers, the developers, uh, anyone involved in the decision process as well, everyone involved is responsible for. Okay, thanks, Kim. Thank you for that notification. Yeah. So every person involved in the creation of AI at any step is accountable for having an impact on the system. There was recently a survey done by Stack Overflow in 2019, which asked the same question that, who would be responsible if something goes wrong? And people at that time answered, 60% of the people answered that it would be AI designers and developers who would be primarily responsible. However, I again beg to differ that I think it's everyone involved in the life cycle, from the very investors to the developers, everyone involved, uh, who would be responsible if something goes wrong. Because ultimately, it is humans who write algorithms. We define the success or failure, and a model is only as good as we train it to be, right? So we need to think of all of that. Some, yeah, some recommended steps to ensure greater accountability in our respective organizations. One is that we should make our company policies clear and accessible to design and development teams from day one. But at the same time, we should understand where the responsibility of the company or software ends. As you would see, that there are some artificial intelligence systems which are semi-autonomous. Some are more autonomous in general, not fully autonomous to some extent, but still more autonomous, and some are even less autonomous. So in those cases, it's very important to understand what the capabilities of your AI is and how much of the blame can go to the AI and how much of it can go to the user. It's very important to keep detailed records of your design processes and of your decision making. And it's also important to adhere to your company's business conduct guidelines and other international laws and regulations, such as the General Data Protection Act, which was recently incorporated, etc., etc. Explainability. You want AI is something which is still rocket science to many people. In fact, I've been working as a data scientist. When I look at some of the applications of AI, it is still rocket science to me. So it's very important that our end user is able to understand what exactly is happening inside the AI. We cannot expect them to understand each and every algorithm, but we should be able to find a way that AI should be perceivable to humans. Uh, because as AI becomes more and more widespread, this also becomes more and more crucial. Uh, Explainability comes as part of good design, because if it's good design, it should be able to explain what exactly the AI is doing. For example, if Netflix is recommending you a movie, then Netflix should be able to explain why they're recommending this movie. Um, some recommended steps with respect to explainability: allow for questions and be able to answer them. Decision-making processes must be reviewable, especially if the AI is working with highly sensitive PII, or personal information, identifiable information. When an AI is assisting users with making any highly sensitive decisions, the AI must be able to provide them with a sufficient explanation, the example that I talked about before. And also in cases when entire processes cannot be explained, for example, financial investment, which are algorithms which are very complex. So you should at least be able to explain the intent behind it. User data rights, this is also very important. So much has been talked about user data rights, Facebook leaking a lot of their data to Cambridge Analytica, which is an analytics firm for Donald Trump and Ted Cruz. So it's very important that we protect our users' data, because as part of AI systems, we are continuously taking in a lot of data. There was recently a survey done by Gartner, which found out that 74% of Americans want to be in control of the data, and they think that that is the most important part of AI. 71% of European Union citizens believed that it is absolutely unacceptable for companies to share data. In fact, so much so that they will completely cut off any ties with the company if they find out that that particular company is sharing their data. So the recommended steps for user data rights: users should always maintain full control over what data is being used and in what context. We should provide full disclosure on how their PII is being shared or being used. We should always allow users to deny the access to a service where they do not want their data to be used. And we should be able to forbid use of another company's data without permission when creating a new AI service. Value alignment, again, AI is relatively very objective, but it should be aligned with the values that you have, because people make decisions with respect to context, but we as machines, not we as machines, AI as algorithms, they do not have context. So this is where the responsibility of designers and developers comes in place to introduce context in AI systems. If machines engage in human communities as autonomous agents, then those agents will be expected to follow the community's social and moral norms. Something about fairness, I think this is the most important point. AI, as we saw with the Amazon example, AI can inherently be biased because of the training data or because of the algorithm. So AI must be designed in such a way that it reduces the bias which is there in our models, because humans are inherently biased. So when they build something, it might be the case that they are introducing some of their bias in the AI system. So the role of a responsible team is to minimize this algorithmic bias by doing as much research as they can and doing as varied data collection as they can, and removing, but also at the same time, please remember that removing all the biases is a very unhealthy or a very unrealistic expectation that you have from yourself. It's like trying to eat healthy all the time. You try to do it, but it's just not possible. The different areas where biases can basically creep in when it comes to machine learning model. I'm assuming most of you are familiar with the basic machine learning process. So the three stages where the biases can creep in is when we are training the data. In the data set that we have, that's where biases can creep in. Second could be in the algorithm itself that we have for the machine learning. And third could be with the test data that we are using to basically validate our results and see whether our model is predicting results as we want it to. So these are the three places where biases can occur. And what can we do about it? We can do real-time analysis of data, intentional and unintentional and unintentional biases. Okay, 1 minute left. We can diagnose and we can try to mitigate. We can install a feedback mechanism to understand the problems better. And I cannot stress this enough. We should have diverse teams to solve diverse problems of diversity. Oh my God, what a tongue twister. And then we should monitor training and results in order to quickly respond to issues. There is a small thing which I wanted to do with all of you. I wanted all of you to ask these questions to yourself. I do not have much time left. But if you guys can ask yourself the very basic questions of AI ethics, I do not have time again, but please ask yourself these questions. I will share the slides with you. And there is this preamble which I've built where I basically make people say these things. I try to make them say these things after the end of the presentation. So I can, again, share these with you as well. Thank you so much for tuning in. You can always email me at my IBM email ID, which is jatin.gupta1 @ibm.com.